Chapter 8, Location Strategies. This chapter will introduce you to the factors that drive how to pick your next business location, including possible international locations. We will cover 3 methods for defining the best location and understanding the differences between industrial and service locations. Let's look at the decision process when BMW chose to open a new auto assembly plant in Spartanburg, South Carolina. The decision process starts at the country level and then drills down to further define the location. First, BMW had to decide which country to choose. They wanted to make cars where they sold cars. The United States is the largest luxury car market in the world and growing. Labor costs are low and productivity higher in the United States than in Germany. In addition, shipping costs are lower and new construction means that the latest methods can be used. Thus, the United States was chosen. Within the United States, a state was to be chosen. Lower wages and government incentives drove the selection of South Carolina. The new BMW assembly plant opened in 1994 after an investment of over $7 billion. Here are some key specifications regarding the facility and its impact on the local economy. Check out the video in YouTube at the link below. Location selection is one of the most important decisions made by a business. This decision is expensive and risky since it typically takes years to recover the investment. Are your forecasts accurate enough to plan that far into the future? The location strategy helps the business choose whether to expand or close an existing facility, add new sites, or relocate to a new site. Location decisions are difficult to change once committed. Both fixed and variable costs must be considered. Are the skilled people available at that location? Are supporting industries available? For example, are outsourcing partners available locally with the necessary skills? Ultimately, it comes down to revenue. Industrial location affects shipping costs, production costs, and labor costs. These costs will vary by location. For a service business, costs will vary less between sites. On the other hand, location directly affects the amount of customer contact and the volume of business for a service. Global location options add complexity. Businesses look to global locations due to market economics, ease of communication, especially with the internet, available transportation, and lower labor costs. To structure the decision-making process, key success factors are defined. At the country level, many of the key success factors are listed here. Politics, culture, market location, available talent, infrastructure, and exchange rates drive the decision at this level. Once the country has been selected, a region and/or community must be chosen. The key success factors here are similar to many at the country level, but become more refined. We also consider environmental regulations, incentives, availability of raw materials, and customers, along with the cost of construction. The final site selection will be driven by site availability, access to transportation systems. Zoning restrictions have an impact along with the availability of needed services and supplies. Customer demographics also must be considered. Do the people in the area need your product or service, and do they have the funds to purchase your product? When considering labor costs, we consider both wages and productivity. We calculate the labor cost per unit by dividing the labor cost per day by the productivity. In this example, we see that the labor cost in South Carolina is not as bad as it first appears, since workers are more productive. When making international location decisions, exchange rate can have a major effect. Remember that location decisions must pay back over time. During that time, changes in exchange rate might be beneficial or cut anticipated margins. When making a location decision, cost is a primary factor, but we must also consider the intangibles. These might include available education, public transportation, community, and quality of life. A remote location may not be able to attract skilled talent for these reasons. In addition, location decisions must also consider ethical guidelines. Do you want to consider a location that, while inexpensive, is known for human rights violations? Other factors affecting location decisions include the government's attitudes towards intellectual property and zoning. What is the stability of the workforce? You might train a skilled workforce only to have them go to the new facility built nearby by a competitor. Worker attitudes must be understood along with cultural beliefs that may conflict with your corporate culture or mission. Proximity to markets is very important, especially for service businesses. High transportation costs also drive the need to be close to markets. In addition, key suppliers must be available. It is not unusual for key partners to build a facility near your new facility. Clustering is where similar businesses locate in a single area. This is often due to common needs, available natural resources, capital, and talent. This is common around the globe. Did you ever notice that a Burger King shows up down the street from a new McDonald's restaurant? You find car dealers clustered together in one part of town. In India, high-tech companies are clustered into cities where talent is available, often due to the existence of a local university. Here are some other examples of clustering in the United States and around the world. Pay attention to the reasons for clustering. This table describes additional instances of clustering and the reasons for clustering. Often the reason is simple. If you see a competitor open a new location, study their activity level. Do they have many customers? If so, why not locate there as well? Here are some additional examples of clustering. If you think about your current organization, are competitors located nearby? If so, what reason would there be for clustering? The first method we'll discuss to help in the selection of a new location is the factor rating method. This is essentially the weighted scoring approach used for the analysis of other decisions. We start by defining and weighting the key success factors. You might use those shown earlier in this presentation as a starting point. Then you identify the alternative locations, scoring each. Then by multiplying the weights and scores and summing the products, you will have a numerical score for each location. If one location clearly stands out, that is your choice. If two or more options have similar scores, further analysis may be called for. Here's an example applying the factor rating method to the choice between France and Denmark. The key success factors are listed on the left with the weights and scoring near the center. The calculations are completed to the right. The totals show that France would be selected, but the scores are relatively close, so more analysis should be considered. Another approach is to use the location cost volume analysis method. Once the location options are defined, the fixed and variable cost of each is calculated based on the expected production volume. For this example, we use the location cost volume analysis to compare Athens, Brussels, and Lisbon as potential locations. We start by estimating the product selling price at $120 and expected volume at 2,000 units. We estimate the fixed and variable costs for each location and then calculate the total cost for each. For Athens, the total cost would be the fixed cost of $30,000 added to the variable cost times the volume, or $75 times 2,000 units. So we have $30,000 plus $150,000 for a total cost of $180,000 for Athens. Similar calculations can be completed for Brussels and Lisbon to see a comparison of total cost. For a volume of 2,000 units, Brussels would be the choice. Taking the analysis one step further, we determine the crossover points. This is the volume where the costs of two alternatives are equal. Comparing Athens and Brussels, we equate the cost equations for the two locations and solve for the volume x. We find that the crossover point for Athens and Brussels is 1,000 units. Similarly, we calculate the crossover point for Brussels and Lisbon and find it to be 2,500 units. Confirm the accuracy of these calculations for yourself. Taking the results of the example and plotting them on a graph, we can see the clarity of the crossover points. With volumes less than 1,000 units, Athens is the choice. Between 1,000 and 2,500 units, Brussels is the choice. Above 2,500 units, Lisbon is the choice. Again, we are looking at the lowest total cost. At the forecast volume of 2,000 units, we confirm that Brussels is the choice. If the forecast volume is near one of the crossover points, we might revisit the analysis in case our volume forecast varies. For example, if our forecast was 2,400 units, Brussels would still be the choice, but we might consider Lisbon if we believe that our volume will increase over time. The next method we will consider is the center of gravity method, which minimizes distribution costs. As with previous analysis, the goal is to meet customer demand at the lowest cost. This model takes a different approach, looking at the location and forecast volume for different markets. The shipping cost to each market is then calculated. On a grid, the geographic location that minimizes the cost is the center of gravity. Mathematically, the center of gravity is determined by the sum of multiplying the quantity of goods moved to or from a given market location times the coordinate of that location divided by the sum of the quantities. This is done for both the x and y coordinates. Applying the center of gravity method, we start with the 3 destination points and the quantities shipped to each. These quantities are your Q values in the equations. The quantities can be per month or per week as long as they use the same reference point. Graphically, overlaying the various destinations on a grid, we see that Chicago, with a shipment quantity of 2,000 units, is located at x equals 30 and y equals 120. The quantities and coordinates are shown for all 4 locations. Here we substitute the x-coordinate data into the top equation to find an x-coordinate of 66.7 and the y-coordinate data into the bottom equation to find a y-coordinate of 93.3 on the grid. Going back to the grid, we see the center of gravity result plotted at x equals 66.7 and y equals 93.3. This is obviously an approximation as it does not take into account highway routes and traffic patterns. Also, the exact coordinates might be in the middle of a lake or river, not a good location. This is a starting point on the map. You would consider possible sites near these coordinates for future examination. A broader transportation model uses complex linear programming to identify the lowest cost location based upon a number of inputs including volumes, production costs, transportation costs, and other factors. These methods are beyond our scope here. This diagram shows the resulting flow of vehicles and parts for Volkswagen. The flow of engines and other major assemblies are shown in red, parts are shown in black, vehicles for final assembly are shown in green, finished vehicles are shown in blue. It appears that every car has thousands of miles on it before it is driven for the first time. Now, when considering services, location can be even more important. Typically, services are located near customers and must be compatible with the demographics of the served area. The location must consider the visibility to customers, uniqueness, level of competition, and available staff. This table compares attributes of services versus goods producing organizations. Services tend to be focused on generating revenue, while manufacturers focus on cost. For services, customer volume and revenue are driven by the local demographics, competition, advertising, and pricing. The physical quality of the location directly impacts customer satisfaction and the likelihood of repeat customers. Service cost is driven by rent, management, hours, and wages. The cost focus for manufacturers has been discussed previously. The primary components are repeated here. For service location strategies, methods include regression models, factor rating method, traffic counts, demographic analysis of the area, local purchasing power, the center of gravity method, and geographic information systems or GIS. The assumption is that location is a major determinant of revenue. Customer contact is critical and the costs are relatively constant for the area. Your cost for a given item will be similar to that of competitors. For manufacturers, the techniques have already been discussed. The assumptions are that low customer contact allows a focus on tangible costs. For the hotel industry, location is critical. La Quinta Inn started with 35 independent variables in a regression model to predict success. They refined this model after determining that 4 factors had the greatest impact. These variables are the price of the inn, income levels of the area, state population per inn, and nearby colleges. Statistically, 51% of the probability is predicted by these four variables. This outcome simplifies their analysis since the required data is generally available. Geographic information systems were mentioned earlier. GIS tools enable more complex analysis. These are purchase tools that include census data, maps, utility availability, geographic features, and locations of major services. These tools are used by major property managers and consulting groups due to their cost and learning curve. Here is a typical output of a geographic information system. The proposed location is centered with demographic and topological data displayed. This level of analysis provides detailed insight into the pros and cons of different locations. Considering the long-term commitment and costs associated with location selection, a thorough understanding is called for.